Welcome back to ME 397 Product Design Laboratory. In this segment, I'm going to talk to you about the reverse engineering and redesign project that you'll be working on this semester and give you some guidelines on choosing a product that will be the focus of your project. And so, as I've stated in the earlier segments of the course, the content of this course consists of presentations of current engineering design methods and techniques. And these are best learned by practice. And that's why we call this course a laboratory. So instead of traditional homework assignments and tests, you're going to demonstrate your understanding of these methods by applying them. And through the years in teaching these methods, I've learned that one of the most powerful ways to learn these methods and practice them, certainly in the beginning, is applying them to an existing product, because it's a lot easier to apply certain of these techniques when you have something in front of you. And so that's what you'll be doing. You'll be applying the methods to a product of your choice, a consumer product, that you'll reverse engineer and then subsequently redesign, attempting to improve its performance in some way. And so what I want to do in this segment is talk through the criteria that I'll use to judge, and that you'll use to judge whether a product is appropriate for this class. And in order to make sure that we're all on the same page, as your first assignment, you'll submit a short proposal about the product that you want to, that you're proposing to use as the focus of your project. And so I'll want to see enough detail with respect to the criteria that I'm going to present that will allow me to make a judgment about whether I think the product is appropriate for the project as well. And so here is a summary of the product selection guidelines that are given in the actual assignment that's available on Canvas. And we'll go through these one at a time, and then I'll show you some examples from previous semesters of teaching a similar class that were successful redesign products that were redesigned by students. So the first criterion is that the product should be a black box. In other words, I don't want you to be able to see through an outer case or something like that to see immediately how the product works. Because part of what we're going to do is go through an exercise of predicting what's inside the product before we disassemble it and find out what's actually inside of it. And if you think about that, you might realize why that might be important in any product redesign effort. And I'll let you think about it a minute. And an important reason is that if you see immediately how a product works, you may be biased in thinking that, maybe even subconsciously, that's how the product should work. Whereas if you predict ahead of time without knowing how the product actually works, if you predict how it could work, you might come up with a better idea, and that might lead you to a better design. And so I want you to go through that exercise. And so that's an important criterion. Choose a product that is a black box. If you choose one that comes with detailed instructions that show, for instance, a assembly drawing or such as that, try not to look at those, so that you don't bias yourself by what's there already, and go through so that you can go through the prediction process. Second criterion is that the product should be easy to disassemble and ideally reassemble. And the reason we want to do that is because we are going to disassemble it, and after doing that prediction, so that we understand exactly how the product works. And part of what you might do within the scope of the project in the redesign portion is redesign some of those internal components. So you need to be able to see what they are. in order to do that kind of redesign. So you'll need to disassemble the product, be able to disassemble the product so that you can do that. And then ideally you'd like to be able to reassemble it so that you can put it back together, do some testing on it as well. So you're going to look for products that where at least from as a first cut from the outside it looks like you can, for instance, remove screws so that you can take a case apart. And there are many products that are like it, even inexpensive toys. There are many of those that are disassemblable by removing a set of screws. An alternative to this would be to buy 2 of these, of the products that you choose, realizing that you may destroy one during the disassembly process, so you could keep a second one to use for your testing and so forth. And if they're inexpensive enough, you can do that. And so some products, or the cases, are held together by chemical wells, for instance, and it's impossible to get them open without breaking something. And so that's an alternative, but ideally what you want to do is get something that you can remove some screws and take it apart. Third, you want to get a product that has a readily available customer base, because part of the very early on in the semester, what you're going to be doing is trying to understand what the customer needs are for that product. And as we'll see, understanding customer needs is an important part of any successful product design or redesign effort. And so I'm going to ask you to get out and actually interact with potential customers of this product so that you can understand what the needs are that the product is supposedly addressing. And so in order to do that, to actually meet with people, that has to be something where you can readily do that. And so be aware of that. And part of what you're going to be doing is, in this project, is asking the customers to actually use the product, and as they're using, try to understand what their needs are. So observing them using the product. And so that's an important part of this too. And I can give you a counterexample. I had a team some years ago that were interested in reverse engineering and redesigning a garbage disposer. And that's a very interesting product, especially to mechanical engineers. It's a nice electromechanical device. You know, it's got a motor in it and transmission, et cetera, et cetera. But ultimately, I didn't approve that product. And the reason is there really wasn't a way for them to allow customers to use that product, because most customers were not going to let them come into their homes, remove whatever plumbing they have, perhaps even a garbage disposer they already had, install this one, let them use it, and then take it out. So while it was an interesting product, it really wasn't appropriate for this project. So you need to think about that, and you need to think about, for the product that you're interested in, who the customers might be. And there can be multiple different types of customers that you'll want to interview and have use the product. So think about that as well. So the bottom line is you need to have access to customers who would potentially buy or use that product. Fourth bullet, I would like for you to avoid substantially electronic or software products. These are interesting products, of course. Everyone has a cell phone in their pocket, for instance. But when you take those apart, there's not a lot you can do in terms of analyzing them unless you have access to sophisticated test equipment. Same with software products. You typically don't have access, for instance, to source code so that you can actually reverse engineer and redesign it. So again, while these are interesting products, they're really not appropriate for this project. And since this is a mechanical engineering course, I'm going to ask you to limit yourself to products that are substantially mechanical or electromechanical in nature. Number 5, and this one is a little bit tough to do ahead of time, but I want you, as you're choosing a product, to think about performance metrics that could be measured or modeled, because that's going to be the focus of your redesign efforts. You're going to try to improve some aspect of the performance of the product. And so you need to be able to predict how your redesign will, whether it will improve the product or not, the performance or not. And so you need to think about what the performance metrics are that can be measured and then are modeled. So it could be either physical measuring or it could be an analytical model, so that you can do that prediction. And think about that. Again, it may be difficult to predict ahead of time. A lot of times it changes as you go through the reverse engineering process. But I want you to think about it ahead of time, because what I don't want to do is get to the end of the semester and find out that there's really nothing you can model there, or really nothing you can measure. So think about that ahead of time. I'm going to suggest that you limit yourself to about $100 for your product. You can get plenty of interesting products for substantially less than that. And so keep that in mind as well. But I think if you're spending over $100, it starts to become expensive, and you may not want to actually take apart something that cost you over $100 for fear that you might break it. So I'm going to set that as the limit. I would suggest looking for something in the $25 to $30 range, and there are plenty of interesting products. I'm going to show you some examples. There are plenty of interesting products that are in that price range, $25 to $30. Next, it should be a product that's interesting to you, because I want it to be self-motivating. I want it to be something that perhaps it's something you've always wondered how it actually works. And so it should pique your interest, and that way you'll stay motivated to work on it for an entire semester. Remember, you're going to have to live with this product for the entire semester. And so if you're interested in it and interested in how it works, interested in improving it, you're more likely to do a good job on it in the project. Last bullet just gives some examples of product classes that have been useful in the past. So things like appliances, such as kitchen appliances, power tools are always popular, toys, etc. These are all good candidates. And let me show you some examples from the past. So here's one. This is just a clamp. It's a Black & Decker clamp, and it's actually an automated clamp in the sense that it's got, as I remember, it's got a little motor in it that turns a lead screw that causes the clamping action. And you can see on it where there's some screw holes, etc. right here, so that it comes apart pretty easily. And it has a little motor in it somewhere, a nice, interesting drivetrain. And you can predict that it has those at a very high level, has those components in it, just by looking at the package, and that's okay. I mean, you're gonna predict that anyway. The real question, though, is what is the actual configuration of the drivetrain? You really can't tell by looking at it. And so those are the surprises that you have when you take it apart. Here's another one. This is a travel cooler. So it's a rolling soft side cooler with it looks like a piece of luggage with a slide down handle and wheels, but it's actually a cooler. Here's an appliance, a juice extractor. I know this is on record, and I probably shouldn't say this, but I'll tell you, Black & Decker brand, those are always good choices. You'll see several examples of those in the slide set, because they're not necessarily top of the line products. They're usually mid-range products. They work okay, but the point is they leave room for improvement, and so that brand tends to be an interesting one to choose for this type of project. Now that I've said that, I'm going to deny that I ever said that in case Black & Decker comes looking for me. Here's a coffee grinder from Krups. So again, electromechanical device. You can predict ahead of time just by looking at this picture that it's got a motor in it, some kind of drivetrain, etc. And so you start to see a pattern emerging here that most of these products have those components, and those are the interesting things that we as mechanical engineers um, like to design. Here's a electric French press, and this is an interesting product. If you're a coffee connoisseur, I think the student who did this was a coffee connoisseur. Liked French press. French press coffee is considered by many people to be the best way to make coffee. So this is an automated version of that, so that presumably you can set it up in the evening and wake up in the morning and your coffee's ready, and it's French press coffee rather than drip coffee that most coffee makers make. I had another student, not the one who did this, another student who was very interested in that and actually ended up redesigning or designing a new automated French press process, and ended up applying for a patent on it. So that was in a different class. It wasn't this student, but so that's an example of being interested in something, being interested in the product that you're working on, in the project, can lead to interesting results, including potentially lucrative results. Here's a Nerf gun. We've done lots of Nerf guns over the years. They do, again, you can see the screw holes. They're very interesting. And Nerf continually comes out with new models of these. So if you're interested in that kind of thing, these are good products to use for this project. And I know that there is a community out there on the internet that hacks Nerf guns trying to improve their performance. So you'd have, if you're interested in Nerf guns, interested in hacking them and improving them, you'd have a ready customer base out there of power users, if you will, of Nerf guns that would probably be very very willing participants in things like surveys and whatnot. I always say that there's a lot of people out there in the world with not much to do, and so what they do is they hack Nerf guns. Here's again, keeping with the theme, Black & Decker handheld vacuum cleaner. So again, you can imagine it's got powertrain, motor, etc. And so very interesting electromechanical device. Here's a cordless impact screwdriver. And as I recall, the student who worked on this was really interested in understanding how the impact functionality was actually realized, and it was surprising to him when he learned it. So this is a Ryobi. If you go to some place like Harbor Freight Tools, they're relatively inexpensive tools. You can get something like this for probably 20 or 30 bucks and not feel too bad about taking it apart. So that's another source of products for this project. The student who did this one, I think he was doing research in robotics, so he was attracted to this. And again, you can see the theme, drivetrain, motors, etc. I have a soft spot in my heart for hair dryers, and this is one a student actually did. But also in another version of this course, shortened version, that I've taught before to high school teachers. What we do is we reverse engineer as a class, reverse engineer hair dryers. And so they're very interesting, and I chose a hair dryer for that class on purpose because I wanted something where the women in the class would be the expert users. So I wanted to get away from things like the drill and so forth that would be things that probably are more attractive to males, although not necessarily. But I wanted something without gears in it, and I wanted something deliberately that where the women would be the expert users. And so it's a lot of fun. So there's a lot of information actually about hair dryers, and hair dryers are actually very interesting devices. So if you're interested in that, again, you can get one of these for 20 bucks and do everything you need to do in this class. This is a camp stove. I think this was maybe the last time I taught the on-campus version of this course. One of the students chose this product. And as I recall, this is a camp stove that can burn anything that's lying around, any kind of organic material. It doesn't take a fuel or anything like that, so you can put sticks and wood in it, and it will burn that and boil water. And then here's a hand crank LED lantern. So again, it's hand crank, so there's a transmission there. Instead of a motor, there's probably a generator, maybe a battery. I don't recall, but that might be what you predict based on using the product. So again, very, very mechanical, electromechanical, and lots of interesting things to model. And then here's a Black & Decker food processor that was done recently as well. So again, motor, transmission, etc. So those are some examples of products. What I'm going to ask you to do is, again, write a short proposal. Maybe include a picture of the product, or at least a link to a website. And in the project assignment, I've asked you to answer and consider specific points. They're basically the points that I gave you as the guidelines. So you'll do that and turn those in a week or so to get approval for your products, and then you'll be off and running.